Now, sometimes when you decompose a fraction, you're going to get denominators of an irreducible quadratic factor. So we're going to look at an example like this. It's really not too hard. You just have to remember one certain thing. Now we can factor by grouping this denominator here. We can take an x squared out, be left with x minus 1. Nothing comes out of there, so it's really going to be 1. So I have x minus 1 times x squared plus 1. So really, this fraction, we can write it as a over x minus 1 plus bx plus c over x squared plus 1. So your irreducible quadratic factors are always going to have the bx plus c or dx plus e, something like that. So when we do this here, we'll end up getting x squared plus 4x plus 1 is equal to a times x squared plus 1 plus x minus 1 times bx plus c. Doing some mathematics here and distributing, and then foiling the second part. We'll have this. Now we will need to simplify and combine our like terms. So a plus b x squared plus a negative b plus c x plus a minus c. So that means our equations will be a plus b is equal to 1, negative b plus c is equal to 4, a minus c is equal to 1. So when you solve these, it's actually not too hard. You do have to do some manipulations here. But what we'll have, generally you want to try and get everything into terms of a or b or c. So let's just pick the second equation here. I'm going to say c is equal to b plus 4. That means down here, I'll have this, which means I'll end up with a minus b minus 4 equals 1, which means it's going to equal 5. And in this equation here, since c is equal to b plus 4, again, I have a plus b is equal to 1. So my two equations that I need to solve, a plus b is equal to 1, a minus b is equal to 5. When you add down, you get 2a is equal to 6, which means a is equal to 3. So once you solve one of them, you should be able to find the other ones pretty quickly. Now we know that a plus b is equal to 1. That means 3 plus b is equal to 1, which means b is equal to negative 2. And also, since b is equal to negative 2, c is equal to negative 2 plus 4, or 2. So there's your values for a, b, and c. Nice, easy mathematics behind it once you figure out the partial fraction part. So when you rewrite your fraction, we'll have 3 over x minus 1 plus a negative 2x plus 2 over x squared plus 1. Now moving on to example B, we have x cubed minus 1. So this will really factor to x minus 1 times x squared plus x plus 1. There's your irreducible quadratic factor. So when you do this, we'll have a over x minus 1 plus bx plus c over x squared plus x plus 1. Which means you'll end up getting x squared plus 3x plus 2 is equal to a times x squared plus x plus 1 plus bx plus c times x minus 1. Doing some mathematics, you'll notice we'll have ax squared plus ax plus a plus bx squared plus cx minus bx minus c. Get all your like terms together. We'll have a plus b x squared plus ax So A minus B plus C, this will be X. We'll have A minus C.
Hi there.
On the right-hand side, those are your constant terms. So that means your equations will be A plus B is equal to 1, because there's a 1 in front of the X squared. A minus B plus C is equal to 3. A minus C is equal to 2. So when we do this, we'll just put these in. We can solve here. A is equal to C plus 2. That means when you put it in here, C plus 2 plus B is equal to 1. That means B plus C is equal to negative 1. And then we're going to put it in here, into the second equation, C plus 2 minus B plus C is equal to 3. Basically what you want to do, you want to get rid of one of your variables here. So we'll end up having a negative B plus 2C is equal to 1. So here's your two equations that we need to solve for. And if you notice, the B's will drop out quite nicely. B's will go away. You'll end up with 3C is equal to 0, which means C is equal to 0. So if C is 0, that means A is going to be 0 plus 2, or 0. Sorry, 2, not 0. And then we also need to solve for B here. You'll have negative B plus 2 times 0 equals 1. That means negative B will equal 1, which means B will equal negative 1. So there's your answer there. To start off, so if C is equal to 0, B is equal to negative 1, A is equal to 2. So if you put it into your equation here, A is equal to 2, so we'll have 2 over X minus 1, plus BX, B is negative 1, C is 0, so you don't have to write it. And there's your partial fraction decomposition. Now in example 5, we're going to be decomposing a fraction with a repeated irreducible quadratic factor. I know it sounds like a lot of fun, and it is. So when we do this, because it's an irreducible quadratic factor, there's really nothing to factor on the bottom there. So I'll end up with ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 squared, which means 2x cubed minus x squared plus 5x will equal ax plus b. And since x squared, the first fraction, is missing one part of the denominator, we'll add that to it. The second fraction isn't missing any part of the denominator. So when you FOIL the first part out, we'll get ax to the third plus bx squared plus ax plus b plus cx plus d. Combining your like terms, there's no terms alike with ax cubed or bx squared. But there is one for x, a plus c, x, and then we'll also have b plus d. Now, using your powers of intuition, that means a will equal 2, b will equal negative 1, a plus c will equal 5, b plus d will equal 0. So when we do this here, 2 plus c equal 5, which means c will equal 3. Negative 1 plus d equals 0, which means d will equal 1. So there's your A, B, C, and D, nice and quick and easy. So what we'll have 2x minus 1 over x squared plus 1 plus 3x plus 1 over x squared plus 1 squared. Now you put this in your calculator. Here's what we'll have. 2x to the third minus x squared plus 5x So there's that one there. Now our second equation, we'll have 2x minus 1 divided by x squared plus 1 plus 3x plus 1 this should work out. There you have it. Those two equations are exactly the same thing. So there's your partial fraction decomposition. Now again, remember that partial fraction decomposition is mainly used for integration by parts. It makes it easier to find the area under a curve if you can use partial fraction decomposition. That's why we're going through it now. Moving on to B, again, we'll have ax plus b over x squared plus 2 plus cx plus d over x squared plus 2 squared. Simplifying this, we'll have 2x squared plus 4x minus 1 is equal to ax plus b times x squared plus 2 plus cx plus d. Doing some mathematics and simplifying, we'll have ax cubed plus bx squared plus 2ax plus 2b plus cx plus d. So we'll have ax cubed, bx squared, 2a plus cx, and 2b plus d. Which means a will equal 0 because there is no x cubed term. B will equal 2. 2a plus c will equal 4. 2b plus d will equal -1. Well, we'll have 2 times 0 plus c equals 4, which means c will equal 4. And then 2 times 2 plus d will equal -1, which means d will equal -5. So there's your answers for that partial fraction decomposition, A, B, C, and D. A is 0, so we don't have to write it. So we'll have 2 over x squared plus 2 plus c, which is 4x minus d, which is -5 over x squared plus 2 squared. Now again, you can check it on your calculator. That's what we have there. I realize it's tough to see, but let's zoom in once, just to show you a little bit better angle of it. As you can see, the second graph is going directly over the first graph, which makes it the same exact equation.